Hey, sixth graders, it's Miss DeBarrio coming to you from my kitchen again. We are back to weather patterns. This time we are on chapter 3. We're going to be talking about wind. So either you have a packet, you have a notebook, piece of paper, pencil, pen, something to write with. You have some material so you can follow along and record your thinking. So we've done Chapter 1, Investigating Rainfall. We've done Chapter 2, Investigating Temperature, and now we're going to explore wind and pressure. So we're going to investigate wind, analyze some data, and then we're going to prepare a scientific discussion, and we're going to post that scientific discussion on Schoology and respond to what other people have written. So since we can't be in the classroom to do a seminar, we're going to do this online. If you don't have access to Schoology online, you can talk to your family or sibling or pet or stuffed animal. Like we can talk to Ruby here. You can find your own stuffed animal to have your discussion with so you can share your thinking. Okay, so this first activity for investigating wind, we're going to think about wind. What do we know about wind? What is it? Do we think it could impact the severity of storms? And how? So take a minute, pause the video, write down your thoughts. Okay. Brief review of our vocabulary. We've done the vocab review a lot, so hopefully you're very familiar with our vocabulary by now. Here's our goal for our lesson today. We're going to define wind and investigate the impact wind has on air parcels and how that could affect the amount of rainfall. We will do this by evaluating some models of wind and exploring the sim. So we have some data provided by the forensic meteorologist. We've looked at this table before, but now I notice that we have a new column. All right, so this column right here is new. We've not seen this before. Okay, and it's about wind. So we're talking about wind in terms of light wind, strong wind, or looks like very strong wind. We could probably also have a moderate wind. All right, so there's some new information. So there's some strong wind here and some very strong wind here compared to light and light wind. What do I notice about the patterns in this table? Well, we have a high surface water and a high temperature, which is our chapter 1 and 2 information. And that's leading to different amounts of rainfall. So I see there's patterns there. And then the wind, the new column, well, we have some severe rain with light wind, but then we have some very severe rain, and I see that there's very strong wind. So I'm wondering if maybe wind is also going to be impactful on how much rain we have. Okay, so let's think about wind and what is it. So we're going to use a balloon. I have a balloon here. I'm going to blow it up. So when you blow up a balloon, you're sort of trapping air. Okay, here's my balloon. My balloon has a hole in it conveniently, and where the hole is, I can feel on my face or on my hand, I can feel air moving out. And you can see that my balloon is getting smaller. All right, so what happened? I filled up my balloon with air molecules, and from our previous units, we know that molecules take up space. And when air molecules are trapped inside this balloon, you could see that because the balloon got bigger, right? It was holding the air molecules. But the thing about the air molecules inside the balloon versus outside the balloon is that inside the balloon, they were kind of like an air parcel. So inside the balloon, we had an area of higher pressure. And outside the balloon, we had an area of lower pressure. So let's take a look at our packet and see what that says. Pressure relates to how much something pushes on something else. Air molecules have weight and can apply pressure on different surfaces. The air molecules apply to pressure against the rubber of the balloon, creating high pressure inside the balloon and low pressure in the surrounding air. When you released the air that was trapped inside the balloon, the molecules moved quickly to the outside, resulting in the wind. So that was what I was feeling. The hole in the balloon allowed the air to escape from the higher pressure area to the lower pressure area, and I could feel those molecules. How does that relate to wind and our atmosphere? In our atmosphere, the air pressure is caused by the weight of all the air molecules pushing against the surface of the Earth. In some areas we have high pressure, and in some areas we have low pressure. Okay, so that's going to relate to our air parcels and our surrounding air. And that's going to bring us to a definition of wind. Wind is the movement of air in a particular direction. We're going to look at some images. We're going to use balloons again and fans, but we're going to look at some images to help us further understand how that surrounding air pressure change can impact air parcels and clouds. Okay, so here we have an image of a fan and it's blowing. Everybody's probably stood in front of a fan at some point. You feel the air on your face, or you see it moves your hair. It's going in this direction. See the little arrows? It's blowing this way. So if we take our balloon or our air parcel and we put it in front of the fan, what's going to happen? It's going to blow this way, right? What happens if we have a bunch of fans? So here we have a bunch of fans pointing at each other, and this is blowing air from all different directions. So in the real world, sometimes we have air that just blows one way, and sometimes it feels like the air is kind of coming from a bunch of different directions. So these fans are representing air coming from a bunch of different directions. And here we are, we have put our air parcel in the center of it, and what happens when you get this air from all these different directions? You get your air parcel getting pushed up faster. So in our model, it's always good to connect our model to the real world when we make a model. The balloon is the air parcel. The space between the fans is like an area on Earth. And the fans are representing the wind that's coming from the various directions. All right, so your job now is to describe in your own words what happened in the model and how it's connecting to the real world. And then, how do you think wind might impact the amount of rain a cloud produces, based on what we've learned so far? Now we're going to look at how wind functions by using the sim. So in our weather patterns sim, we're going to gather some evidence about exactly how the wind can affect the cooling of an air parcel. So we've got some instructions in our packet of how we're going to set up the sim. We've got a table that we're going to collect some data on, right? Okay, so here's our table. Ta-da! Here's our directions. So I'm going to get the sim up, and then we're going to walk through it together. All right, here's our sim. So we have our surface to sunlight to surface, right? We have our surface water, and then we now have these pressure at air parcel and pressure around air parcel. So let's see what we're supposed to set our sim at. So it looks like our sunlight to surface and our surface water are going to be at level 3, all right? And our pressure, we're just supposed to set our pressure to create some wind, okay? And then we're going to press run and analyze. So then let's see what we have here. We want some wind versus some no wind. Okay, so I see that we're going to run 2 tests, one with wind and one without wind. Okay, let's get to it. All right, so we want wind. Okay, here's a bunch of wind. What happens if we turn some wind up here? We've got our surface water at 3 and our sunlight at 3. Okay, let's go. See what happens. I see our sunlight coming down, and it's increasing the temperature in the air parcel. All right, I see that we're absorbing some water vapor into the air parcel through evaporation. I see we have a temperature change as it's rising and energy is going out. And I see some rain. I see that our troposphere height is at 6.7. Okay. So let's do some analyzing. So if we get the data, I'm going to have to move my screen so we can all see what's going on. All right. I'm looking over here now for my data. Okay, we got a rainfall of about level 2. All right. And then I see that my troposphere height is 6.7. Okay. What happens if we don't have any wind? Does it change? So if we have no wind, and our surface water is at 3, and our sunlight is at 3, let's see what happens if there's no wind. Okay, I still see my energy coming down from the sun. I see that my air parcel on the screen there's some evaporating of the water. It's been pulled up. Energy's out. Oh, look, we're done. Do we have some rain? We have a little bit of rain. And I see that my troposphere height is different. It's lower. Okay. And my temperature, I believe, is also lower. It did not rise as high without the wind. And our rainfall level is lower. So our rainfall level is only a 1 here. Okay. So let's go back and look at our data table. Okay, here's my data table. So in my parcel 2 with no wind, my parcel height was 5.5, and my air parcel final temperature, I think, was -25. Take a quick look. Yep, 5.5 and -25. And my rainfall level was 1, and my energy out was 108. All right, so I put that all into my chart. Now I'm going to go back and I'm going to run the one with the wind again so that we can see that one more time, how that was impacted. Okay, I'm leaving my sunlight alone. I'm leaving my surface water alone. I think I gave myself a little pressure at the parcel, and I gave myself a lot of pressure around the parcel last time. Let's run it. All right, see what's happening. All right, we're gathering our water vapor. We've got our temperature. Whoa, I saw some wind. That time I was paying attention. It was fast. All right, so now we're done. I'm looking at those same, going to get the same kind of data. So I want my troposphere height. I want 6.7. I want my air parcel temperature, -30. And then I need to look at my analyze to find out my rain level and my energy. All right, rain level was 2, and energy out was 121. All right, I can record all that information in my data table now. And then I can look at this data table, and then I can think about, does wind affect the amount of rain, and how? So I think I have some good data that I could answer that question. So that's going to be your task, pausing the video and answering that question. And then we're going to come down here and fill in our key concepts. So these are the big ideas from this chapter, this first lesson in this chapter. The air moving from areas of blank pressure to areas of blank pressure is wind. So you think you can fill in which is high and which is low? And then air parcels can be pushed up into the troposphere by, what are we studying in this lesson? That's the word that's going to go in that blank. So now, check yourself. Did you get it? Look at the data table from the beginning of the lesson. Why do you think Storm 4 was so much more severe than Storm 3? Why did it have more rainfall? Can you do that? Can you answer that question? You have a bunch of data now to figure that out. All right? So to summarize this particular lesson, our key concepts are air moving from areas of high pressure to areas of low pressure is called wind. And air parcels can be pushed up into the troposphere by wind. And yes, there's some good data to suggest that the higher an air parcel rises, the greater change in temperature, which leads to a greater amount of rainfall. And what we noticed in this lesson is that wind will push the air parcel even further up, resulting in more rainfall. So what are we going to do next? We're going to analyze some more evidence and some more data, and then we're going to get ready to organize our thoughts for our discussion, which is coming later this week. All right, guys, take it easy. Until next time, bye.